everyone. Here I am Vadel Sagar. Let us continue our discussion in the chapter number 1 in electric charge and its field. Okay, so at last we seen about the electric field in detail. Here I am taking the example number 1.7 of the NCERT 12th physics books, and this is also related to our discussions. And actually, this is about Coulomb's law, and but we are end up with the electrical field also. At the next topic also, this is about the electrical field, but before that we have to go for the some coulombs regarding what is the force on the each charge. Regarding the coulomb's force we have to talk about. This is little bit more complex system, as you can able to see here. So they are asking about the consider the charge q minus q placed at the vertex of the equitriangle angle. So as you can see, at the top of the triangle minus q, here the q and q, what we have to find, let us see what is the force on each charge. Okay, the force on this charge, force on this charge, force on this charge, we have to find. So let us go for the solutions. Don't see that what the complexity is shown here. I will introduce in a very simple way. You will able to understand at the end. If you have any type of query regarding the discussions anywhere, anytime, you can comment on the YouTube sections. I will answer it in the by call or any way of the comment also. Okay, let us see what are the force components are there. Now it's a very easy what we are already done in the Coulomb's law and others electric field, that based only. Okay, trying to focus on these two charges because the forces are only applicable or the it is having between the two charges. That another two can be, but first of all you have to see the any two charge. Okay, these two charge I am seeing this force. Now this one thing is new for you now. This is negative charge and this is positive charge. Two unlike charge always attract. So there, what up to this what we are discussing, we are drawing the our force arrow is opposite in the manner. But here in the first case, as we have discussed, the here we have attractive force. That's why you can able to see this arrow is towards the force. What the force, as think about it, two body which are attracting each other, so they are inward force they feeling. Okay, so this is F31. As we discussed, what is F31? Force on 3 due to 1. This is F13. It is a force on 1. This is actually Q1. That's why force on 1 due to 3. So this is both are inward. It's a up, both towards the each other. Okay, here also this system and this system, so the same discussion. This is negative charge, this is positive charge, so that's why they are attracting each other. F3 to F3, F23. Now talk about these two, because these two is similar charge, it means positive charge. So again, as we discussed earlier, as per our knowledge, they are repelling each other, so they we are drawn the arrow is awaying to the, which it means the force is repulsing force, so it's awaying force. So the F12 is a force on 1 due to the second particle. This is second particle. F21, the force on 2 due to the first particle. So yes, each and every particle 1 2 3 having two other forces, because other two particles are present. For this two is present. For this and this are present. For this and this is present. So yes, so that for each particles, each charge particle having two another forces are present. Now these two forces are having some angled, so we can apply parallelogram for this particular. Okay, here we have F12, F13. The resultant will be, okay, this already we discussed, but still I write here, so you have to understand. F12 is along the F12. Where is F12? Yes, F12 is along the AB line. Along the AB line is a set of forces on A. F13, F13. Okay, F23, F23, F21, F21, set of forces on B. F31, F32, set of forces on C. That for simply what we discussed is written here. Okay, now this is a first section and this is second section, then answer. So trying to see from the here, the result force on the Q and Q at A due to the F forces and F13. Now resultant force we have to find, because there is a two forces are present, so resultant force where our A will feel resultant force. This you can think it about like a you can raise your hand in a front of you, and one your right hand you are raising a sideway. Now one fellow who stretching you in the right side, and one fellow you are stretching you in a forward direction in the front of you. So where you move, you are going to the right side or the front side. You are not going either side, you will go at the angled in between A. So this is what I am trying to understand you. This is f12 is nothing but the sum of it's a parallelogram rules tells us. This is f12, f13 resultant is f1 I am indicating. This is nothing but this one. Okay, sorry. uh, yes, this f1 is resultant force. As you can see, this two sum is the f3 f2, and this two is resultant one f3, as I mentioned here. This is same as you can applying for the B. F2 is equal to F21 and F21. The directions of F1 is along the BC and F2 along the AC. How you can judge? See, the F1 is, I can fit it into the here. See, so I can say F1 is along the BC, B and C. F1 is along BC and F2 is along AC. F2 and yes, alignment. This is AC. So this is alignment about the result force on Q3, resultant force on Q3, which is negatively charged, is having charges is forces is F32 and F31. The resultant will be the F3 only, which is downward. It's a bisectorial way. It means the bisector half of the triangle. It's called bisector. Bisector directions it follow F31. Okay. Now the magnitude of the force between those charges. Now what about this? Yes, whether we are judging here this it is attracting force, repulsing force, it's okay, but how much? So as per our Coulomb's law, two charge multiplications divide by its respective distance between it, and then it's a multiplied to the k. So the k, q1 q2, where our q is equal to q and q2 is equal to minus q. But we are not bothering about the what direction it has, what forces we have. We are trying to see that how much magnitude. So I'm taking a minus q, mode of minus q is a q. So that ultimately q is equal to q square, and the distance between two charges is L. So I can write able to F is equal to k q square upon L square. This is all where, because all where q distance is L, q distance is L. So the all where the forces are the same. That's why only one time I'm writing this final formula for the Coulomb's law applying on the equitriangle charges. Now the directions point of view you are trying to see. This is the main part of this example. As you can see in figure, the f3 is having downward side, f3 downward side. This vector you can shift it here, this vector is shifting here. Join the resultant vector f1 and f2. Now once the f1 and f2 summed, then resultant vector which is f4, and this f4 is exactly cancelling this f3. So that there is no any resultant kind of force acting on the any charge. So at the end, f1 plus f2 plus f3, which are forces on the respective charges, is going to be 0. Okay. Topic number 1.8.1, electric field due to the system of charges. In earlier cases also we are seen that the Coulomb's law and then the system of charge Coulomb's law. It means number of charges are there. Here also in the previous discussion we did about the electric field, and now here it extended form is electric field due to the system of charge. There is no only one charge, two charge, three charge. We have too many charges. And then what about the electric field? As we know, the fundamental electric field expression is equal to ER is equal to 4 pi epsilon 0 q upon r square into the r particular directions of its. Consider a system of charge which is consisting q1, q2, q3 up to qn with the position vector r1, r2, r3 up to rn. So here you can see q1, q2, q3, q4. and this is our reference point. From there you can make a measurement. So yes, if we are supposing this is a positively charged all are, so it has a outward radiations, so outward radial vectors of the electric field. So this is the E1, this is E2, this is E3. It has on all direction, but we are taking the supposing because towards the our observation point. So the E4, and this all vectors is having some, that one the resultant will be dominating as anywhere. So this is depend on this is called the system of electric field. Okay, so release to the some origin, let us electric field at the point in the space due to the single charge. Electric field at the E1 due to some distance of r with the q1 and r1. So as we seen earlier and the above expressions also, it going to E1 is going to 1 upon 4 pi epsilon 0 q1 r1p, because this is a p point and this distance r we are denoting as r1p, r2 because q2 it's r2p, r3p, r4p likewise. So this is the distance square r1p square and r1p cap, because it's the one of the direction along this direction this force is there. As you can write these expressions for the e q2 also, q3 also, and q4 and so on for the qn also. Now the similar expressions hold good for the E1, E2 and so on. So final resultant electric field going to be sum of the all resulting electric field. So as you can see, the first expression what we see, this second expression what we seen, and so on for the n electric field. And this is our general form where our 1 2 3 4 any values going. So I can write as a summation, I can write as a summation run over the that number. So here as you can see, 1 upon 4 pi epsilon 0 is common out for the all terms. I am writing the summation over I is equal to run for the 1 to n. It means somewhere you can able to see q1 q2 q3. So that 1 2 3 4 is running, so I can represent as qi. So the every time I have to put the q1, then respective I is going to be all r1. Now second term should be the 2, so the q2 and likewise and q1. So here you can also see r1 r1p, r2p, r3p. So I can write as rip square, and here also cap of rip. This is called general form as you already know, but I am let us define in a more detailed way, that's why. So here bold e is tells us about the vector form. The e is the vector quantity that varies from the one point to the another point in the space. So as you know, this line I can understand is a very easy way. If you have a magnet, if you are in a magnet, it has a magnetic field. If you are close to the magnet, so you feel more magnetism, because it is a mean that if you vary your space, if you are vary your place, it can affect different way. That is the what way I am trying to explain this. E is the vector quantity, it can be varies from one point to the another point in the space, and it's defined as the positions of a source charge. Where is the source charge, according it can define. Okay, this is all about the electric field. Now what the significance of it? It's a little bit outward to your 11th or 12th class, sorry, but yes, you have to understand in this stage because it is in the book. For the electrostatic, what is the mean of electrostatic? Electrostatic means it is a field there, steady electron study are happening, it's called electrostatic. The concept of electric field is a very convenient but not really necessary. Electric field is an elegant way to characterize the electric environment of the system of charge. Where you have a system of charge, there is a very important point where we have to discuss. Electric field at a point in a space around the system of charges tells you the force. Electric field is gives the idea of the electric force. As I said earlier also, the force cannot exist without electric field. So as this is the importance of its electric field is the characteristics of the system of charges, and it's independent of the test charge, but that the place of the point determine its field. It's independent to the point charge what is exist. This also we have seen in the expressions in earlier talk. The field, this is a very important, the field in a physics generally refer to the quantity that is defined at every point in the space and may vary from point to point. As I earlier said, electric field is vector field, since force is vector quantity. That the things is different. The forces are vector quantity, and this field is vector field. It has a one field, it has a one region. It can vary point to point. Okay, let us continue the significance of the electric field. The field is this: the accelerated motion of the charge q produce a electromagnetic wave. This is a little bit out of this your station, it means out of your mind. And any charge particle is moving in space, it can generate the electricity, that you know. And that electricity is always generating magnetism. So it is a in between, I can say, they producing electromagnetic wave. That what is they are returning, accelerated charge particles is the generating or producing electromagnetic wave, which, so what why we are discussing these things here? Because there we can take a help of the to solve this, we can take a help of the electric field. So which then propagating in a speed of light, it reaches to the q2 point, causes forces on the q2 notion to the field, elegantly accounting for the time delays and all that. Thus, even through the electric and magnetic field can be detecting by their effect, as I said earlier, on the charges. They are regarded as a physical entity, not merely mathematical construct. They have independent dynamics on their own, because electric field, it has own independent physics. And there, yes, it is nowadays we have a well defined term. It's a electric field, and which is very necessary. For example, they evolved according to the law of their own, as I said. This can also transfer energy, thus, a source of time dependent electromagnetic field turns on a briefly and switch off, leave behind the propagating electromagnetic field. Transporting it can able to transport the energy. The concept of field was first introduced by the Faraday, thanks to the Faraday, and is now among the central of the concept in physics. Thank you very much.